Dear students, welcome to my new channel Explore with Jahid. In today's lecture, we'll learn about hard gelatin capsule and its preparation, manufacturing and evaluation technique. So let's start. Capsules are solid dosage form in which the drug substance is enclosed within a hard or soft soluble shell made of gelatin or suitable material. The word capsule is derived from the Latin word capsula, that means small box. Capsules are formulated for carrying fixed dose of any API. It's a unit solid dosage form meant for oral use in which medicaments and inert substances are enclosed. So there are two types of capsules. One is hard and another is soft gelatin capsule. The hard gelatin capsule, also called two-piece, because there is a cap and there is a body, as it consists of two pieces in the form of small cylinder closed at one end. The shorter piece is called the cap, which fits over the open end of the longer piece called the body. Hard gelatin capsules are intended to contain solids. The soft gelatin capsule is also called one piece and intended to hold liquids. Capsules are available in many sizes to provide dosing flexibility. Unpleasant drug taste and odors can be masked by tasteless gelatin shell. So capsules are solid preparation with hard and soft shell of various shape and capacities, usually containing a single dose of API. So from this lecture, we have understood that hard gelatin contains two pieces. One is cap and another is body, and soft gelatin is one piece and it contains liquid. So this is the basic differences between hard and soft gelatin capsule. It is two piece, it is one piece and hermetically sealed. It is cylindrical shape and soft gelatin is available in round, oval or tube-like shape. Powder, drug or pellets coated with drugs are encapsulated in hard gelatin capsule, whereas liquid and semi-liquid fill and unstable substance are encapsulated. Gelatin is hard form is used and molten gelatin are used. Capsules are sealed after they are filled to ensure that the medicament may not come out of the capsule due to rough handling, and filling and sealing of soft gelatin capsule are done in combined operation on machine. 8 different types of sizes are available, like 000, 000, then 1 to 5. These are the 8 shapes, but for soft gelatin capsule, no specific sizes are available. So let's see the advantages of capsule over other pharmaceutical dosage form like tablet, syrup, suspension or other liquid dosage form. This is easy to manufacture because there are lesser stepwise operations. Okay, during tableting operation, we have seen that drying, mixing, blending, grinding, granulation, compression, coating, these are the overall steps for tableting. But for capsule, the steps are much more lower than that of tableting. We'll discuss this in our upcoming sections. Liquids can be administered. Bioavailability of poorly soluble drugs can be improved. Taste of bitter drugs can be masked. Elegant in appearance. Smooth and slippery surface facilitate swallowing. So in case of tablet, we have seen that its surface is somehow rough, but the capsule surface is smooth and slippery. Okay, it facilitates swallowing. Minimum excipients are only required. Rapid solubility of gelatin allows faster release of drug. Pressure required during the manufacturing is lesser than the required during tablet production. Okay, during tablet production, we have seen that two upper punch and lower punches are compressing the tablet. Okay, but this type of compression is not needed during capsule preparation. However, there are a number of disadvantages of capsule. Capsules are not suitable for drugs that are highly soluble like potassium chloride, ammonium chloride, etc. Because for this suitable soluble drug, it will solubilize the gelatin. Okay, because we are keeping the products into the gelatin. Not a suitable dosage form for formulating drugs which are highly efflorescent, that means that loses water to atmosphere, and are highly deliquescent, that absorb water vapor and convert into liquid. Okay. Efflorescent lead to more softer capsule, while deliquescent lead to forming a more dry capsule. Concentrated preparation that require diluted prior to administration will not be possible to formulate as capsule. So in case of efflorescence, the granules will release the moisture, and by getting the moisture, the capsule shell or gelatin will get softer. But in case of deliquescent, what is deliquescent substance? That absorb water. Okay, the deliquescent substance is just opposite to efflorescence. So deliquescent substance like deliquescent powder or granules which is kept in the hard gelatin capsule will ultimately absorb water from the gelatin and ultimately make the gelatin dry. Okay. So let's see the basic constituents of capsule shell. So the main ingredients of capsule is the gelatin. Okay, because by the gelatin we prepare the capsule shell. Then another one is plasticizer, because it will plasticize the components. Okay, for example, glycerin, glycerol. It imparts the softness, elasticity, and hardness. Next one is preservative, like methylparaben, sorbic acid. It retards the growth of microorganism. Next one is solvent, like oil. Then opacifier, like titanium oxide. It minimizes the transparency. Different colors are also added, like FDNC, DNC, water soluble dyes, certified lakes. Okay, it gives pleasant appearance to the shell. Then flavor, like ethyl vanillin, it provides good flavor. The next one is sugar. It provides taste. Then acid, like fumaric acid, it lessens the aldehydic tannin of gelatin. Then thickening agent like methyl cellulose, it adjusts the viscosity of gelatin. And the last one is water. So we have already seen that gelatin is the vital component of hard gelatin capsule. So gelatin is a heterogeneous product derived by the irreversible hydrolytic extraction of collagen. Common source of collagen are animal bones, skin of ox, pigs. Gelatin's chemical, physical, and physiological properties make it an ideal substance for the capsulation of pharmaceutical products. Gelatin is available in two forms, like type A and type B gelatin. Type A derived from acid catalyzed hydrolysis and exhibit an isoelectric point in the pH range 9, and type B derived from alkali catalyzed hydrolysis and exhibit an isoelectric point in the pH range 4.7. So these are the overall procedure for gelatin preparation. Whatever the source, like dry bone or calf skin or pork skin, whatever the source is, we will firstly wash, then lime. Okay, then we'll extract, filter, cool, sterilize, and finally drying for getting the gelatin. So here is the step-by-step manufacturing process of gelatin. This is the incoming bone, then acidulation, then liming is done. After washing, we conduct the extraction, then filtration and deionization is performed. After that, evaporation is conducted, then filtration, cooling, sterilization are performed, and finally by drying we make the capsule shell prepared for blending. So these are the general characteristics of gelatin, like bloom value, gelatin power, viscosity, hygroscopicity, then polymeric material. There are some general characteristics of gelatin. We have to learn about that. First one is bloom value. It is a measurement of the gelling power and the strength of the resulting gel. Gelatin generally falls between 50 to 300 bloom strength. Then gelling power. The key function of gelatin is gelling power, because ultimately it need to be gelled. Okay, during the hard gelatin capsule shell preparation, we will see that gelling is important. The gelling power varies depending on the grade of gelatin. It's measured in terms of bloom value. The higher bloom value, the greater the ability to form gel. The next one is viscosity. In general, the higher the bloom, the greater the viscosity. Beef bone grades tend to have higher viscosity. Viscosity is determined by measuring the flow time of a 6.67% solution of gelatin through a U-tube viscometer at 60 degrees Celsius. Viscosity measurement is given in millipoise unit and varies between 20 to 70 millipoise. The next one is foamability. Okay, during the gel preparation, the foamability is also an important factor. In general, pig skin grades tend to have better foaming properties. Gelatin lowers the surface tension, allowing for the incorporation of air and stabilizes the foam once aerated. The next one is melting point. Lower melting point gelatin dissolve faster in the mouth, therefore releasing the flavor more quickly for an instant taste sensation. Lower bloom grades tend to have lower melting points. Okay, so this is another factor. The next one is color and odor. Gelatin should be as clearly as possible in solution. Clarity is measured using turbidimeter. The gelatin should be without odor because gelatin has a very bad odor because it's derived from skin, okay, or several other parts of animal body. The next one is conductivity. It's a key parameter in photographic application, and grades of highest purity with minimal or no conductivity are required. The ionized grades have an advantage because of their low conductivity. So let's discuss the overall shape and structure of hard gelatin capsule. So this is the body, which is longer in shape, and this is the cap. Okay, so cap is smaller in shape, and cap is provided on the upper side of the body. The hard gelatin capsule consists of two pieces in form of cylinder closed at one end. The shorter piece is called the cap. The cap fits over the open end of the longer piece called body. The drug substance is placed in the body and the caps are slided over it, hence enclosing the drug substance. Now let's discuss the production of hard gelatin capsule shell, because as you know, this capsule shell makes this dosage form, and it also separates this dosage form, that is capsule, from any other dosage form like liquid, semi-solid dosage form, suppositories or tablet, any other dosage form. Okay, because only this dosage form uses gelatin. Okay, now we need to learn that how this capsule shell is prepared by gelatin. All raw materials required for the production of capsule shell are collected and weighed. So the raw materials are, we have discussed in our previous lectures, that like plasticizer, coloring agent, flavoring agent, gelatin, water. Okay, these are the raw materials. A solution of gelatin with a concentration of about 45 to 60% is prepared by mixing of gelatin in demineralized hot water at 60 to 70 degrees Celsius in jacketed pressure vessel. Vacuum can be applied to remove entrapped air bubbles. Gelatin solution is transferred to stainless steel feed tanks. Dyes, opacifiants, preservatives, and any water needed are added to the gelatin solution. Finally, the viscosity is adjusted according to the required thickness of the capsule shell. Now let's see the step-by-step production of uh, hard gelatin capsule shell. Dipping, spinning, drying, stripping, trimming, joining, polishing. So for shortcut technique, I have learned this as DS TJP. Okay, D means dipping, S means spinning, drying, stripping, T means trimming, J means joining, P means polishing. We'll discuss this one by one. First one is dipping. 150 pair of stainless steel mold pins are dipped into the prepared gelatin solution of controlled viscosity to form caps and bodies simultaneously. So for the overall understanding, please watch this video that has been provided in this link. Okay, I have discussed this as infographic show or animation. So this results in the formation of film on the surface of the mold pins. Next one is spinning. The mold pins are rotated so as to provide uniform distribution of gelatin. Then drying. Gelatin is dried at the blast of cool air to form the hard shell. The pins are moved through a series of air drying kilns which help in removing any water content present. Then stripping. A series of bronze jaw strips the cap and body portion of the capsule from the mold pins. Then trimming. The stripped cap and body portion of the capsule are trimmed to the required length using the stationary knives. Joining. After trimming, the cap and body section are joined and ejected from the machine. And lastly, polishing is done using Excelacota pens and then wrapped with the cloths. The entire cycle of the machine lasts for approximately 45 minutes. Inspection processes are done finally to remove the imperfection capsule. Capsules are then ready for sterilization and packaging. So these are the overall procedure for capsule shell preparation. For the easily understanding, we have provide the video in this link. Please, if you have any confusion regarding the step-by-step procedure, please press this link button. We'll see the step-by-step animation of this capsule shell preparation technique. So here the overall process has been shown. We can see, first of all, dipping. We have dipped the material into the gelatin. Then we conducted spinning for the uniform distribution. Then we have dried. Okay, after the drying, then we perform the stripping because we have to strip the capsule. Okay, the capsule shell. Then cutting in suitable size has been performed. After the cutting, we perform the joining, followed by polishing. So these are the sizes of different capsule. From there are 8 sizes of capsule. For human use, empty capsule shell are available in different sizes. Based on the capacity of the granules, capsule size are numbered and range from 000 to 5. Okay, so it is the largest and this is the smallest. So here we can see the largest one will contain the highest volume or highest size. Okay, the smallest one is containing the lowest volume in ml or is in the lowest size. Okay, only 1.1 millimeter. Now we have prepared the capsule shell, we have the granules. Now our main task is to capsule filling. The hard two-piece capsule can be filled with material that have a wide range of physical properties. So solid can be filled, semi-solid can be filled, also the liquid can be filled here. So there are different types of capsule machine: punch method, hand operated capsule filling machine, semi-automatic capsule filling machine, automatic capsule filling machine. We'll discuss about hand operated machine which is available in our lab. Pharmacists that prepare capsule on a regular or expensive basis may use hand operated capsule machines. These machines are also called Phaeton capsule filling machine. So these are the components of this capsule machine. Capsule bed with 2 to 300 holes, loading tray, powder tray, pin plate with 200 to 300 pins, sealing plate with rubber top, lever, cam handle. So these are the overall structure or the components of hand operated capsule filling machine. We can see the components here. So in one of my video in YouTube channel, I have shown the hard gelatin capsule filling technique step by step. So this is the pin plate, this is the bed having the holes, this is the sealing plate which will seal the cap and body, this is the powder tray which will provide the powder or granules, this is the loading tray which contains the empty capsule shell or the filled capsule, this is the cam handle for the movement of these plates. Okay, the ultimate compression or the capsule preparation will be held in this bed having holes. So if you have any confusion regarding the capsule filling, please watch this video in the link given above. Now I am showing these steps one by one. First of all, tighten the cam handle and placed lever in the position. The machine is ready for capsule filling. Place the empty capsule onto the loading tray with the body end of the capsule oriented downwards and the cap oriented upwards. Place the filled loading tray over the capsule bed. The cam handle is used to lock the body part of the capsule at their place while of the cap of the capsule is separated. Powder tray is placed in position. Okay, the task of the powder tray is providing the powder or granules into the capsule body, and the powder is placed on the surface. Using the spatula, spread the powder uniformly to fill the bodies of the capsule. Remove the excess powder. The pin plate is then lowered to press the filled powder. The task of the pin plate is to adjust the filled powder. Okay, and again raise the pin plate. Remove the powder tray after filling. The cap holding plate is then repositioned over the body. Okay, the loading tray. This is the loading tray which contains the cap still. Now we have to join the cap and body, and the capsule are rejoined by manual pressure. Okay, by the sealing plate. Remove the loading tray and collect the filled capsule. So these are the overall approach. If still you have any confusion, please watch this video given in this link. Okay, now our capsule has already been filled and prepared. Now this is the time for evaluation of capsule. Whether capsules are produced on a small scale or large scale, all of them are required to pass through certain tests. Okay, so these are the quality control tests. We can see here the tests are as the tablet evaluation. The physical tests include disintegration test, weight variation test. Chemical tests include dissolution test, assay, content uniformity, stability testing, moisture permeation test, etc. So these are the tests for evaluation of capsules. So first of all, disintegration. This method is as the evaluation of tablet, disintegration test of tablet. The capsules are placed in the basket rack assembly, which is repeatedly immersed 30 times per minute into a thermostatically controlled fluid at 37 degrees Celsius and observed over the time described in the individual monograph. So this is the dissolution test for capsule. This is the weight variation test, and this is the content uniformity test. The amount of the API should be within the range of 85% to 150%. Okay, of the level amount for 9 of 10 capsule, and with no unit outside the range of 70 to 125% of the level amount. So these are the overall lecture from capsule preparation. If you have any confusion, please inform me in the comment section. Thank you.